Hello YouTube family, you are welcome to provide a solution given this beautiful algebra equation, which is k raised to power 3 subtract k, this is equal to 504. So what is the value of k? Now solution here, k raised to power 3 subtract k, this is equal to 504. Okay, now from what we have here, we take this 504 on the left hand side so that we have minus 544. This is equal to 0. Okay, now we find that k cubed subtract k subtract 504 can be expressed as 512 subtract 8, which is equal to 0. Okay, now 512 can be expressed as 8 raised to power 3. Okay, so let's substitute this. We're going to have k cubed subtract k subtract 8 raised to power 3. Okay, now this is the same as negative times negative. This is the same thing as plus 8, which is equal to 0. Okay, now let's combine k raised to power 3 with 8 raised to power 3. Okay, because the exponent is the same, which is 3. Subtract k plus 8, okay, which is equal to 0. Okay, now you can see that the first part, this is clearly the difference of cubes. That is the difference of two cubes expressed as a cubed subtract b cubed, which we can express as a minus b, a squared plus ab plus b squared. Okay, now from what we have here, we have k cubed subtract 8 cubed, k cubed minus 8 cubed. This is the same thing as k minus 8, k squared plus, this is 8k plus, that is 8 squared, which is equal to 64. Now let's try. We are going to have k minus 8, okay, k squared plus 8k plus 64 subtract into the bracket. This is the same thing as k minus 8, which is equal to 0. Okay, now from what we have here, this is k plus 8, but you can transform it. This is the same thing as k. If you say negative times negative, you're going to get back 8 plus 8. Okay, so this is the same thing. Now you can see that k minus 8 is common, so we factor out k minus 8, so that we're going to have k squared plus 8k. Okay, then this is 64, this is plus 64, subtract 1, everything equal to 0. Okay, we have that k minus 8, this is equal to 0, and that means that the first value of k is equal to 8, okay, which is a real root. This is a real root. This is a real root. Now, from what we have in the bracket, which is k squared plus 8k, this is plus 64. 64 subtract 1, this is 63. This is equal to 0. Okay, now we form a quadratic equation. This is a quadratic equation which is in the form of ak squared plus bk plus c. This is equal to 0. Okay, now from our quadratic equation, we have that a is equal to 1, b is equal to 8, and c is equal to 63. Okay, now let's determine the nature of this the root of this quadratic equation by determining the value of discriminant value, which is expressed as b squared minus 4ac. Let's assess if it is less than 0. Okay, now our b squared, this is the same thing as 8 squared subtract 4 times a, which is 1, times c, which is 63. Okay, so here we have 64 subtract, we have 63 times 4, which is equal to 252. This is 252, which gives us a value of negative 188, which is actually less than 0. Okay, so that means that we have two complex roots. We have two complex roots. or rather imaginary roots. Okay, now to solve for these complex roots, okay, which are in the form of, you can call this one k2, which is a plus ib, and k3, which is equal to a minus ib. So these are imaginary roots. They're in this form. Okay, so let's apply the quadratic formula to solve for these imaginary roots. So we're going to have k is equal to negative b plus or minus the square root of b squared, subtract 4ac, divide everything by 2a. Okay, so let's apply this formula. Now from what we have here, our a, b, and c, we can substitute to the formula, so that we're going to have negative 8 plus or minus the square root of b squared. B squared is 8 squared, which is equal to 64. Subtract 4 times 1 times 63. Divide everything by 2 times 1. Okay, so that you're going to have negative 8 plus or minus the square root of, this is negative 188. Okay, if you say 64, subtract 252 divided by 2. Okay, so that we're going to have negative 8 plus or minus. Now from what we have here, negative 188 can be expressed as 4 times 47 times negative 1. Okay, divide everything by 2. Okay, so that we're going to have negative 8 divided by 2 plus or minus the square root of 4, this is equal to 2. Okay, the square root of negative 1 is equal to I, then square root of 47 divided by 2. Okay, so that we're going to have, if you simplify here, we have negative 4 plus or minus I square root of 47. Okay, so that means that here we have two complex roots, or two imaginary roots, right? Whereby k1 is equal to negative 4 plus I 47 square root of 47, and k2, I mean k, this is supposed to be k2 and k3, sorry, this is negative 4 minus I square root of 47. Okay, so this means that our solution we have got that means that we have three solutions here. We have that k1, which is equal to 8. This is a real root, which is a real root in this case. And we have that k2 is equal to, this is negative 4 plus I square root of 47, and k3 is equal to negative 4 minus I square root of 47. These are two complex roots. Okay, two complex roots, and that's the solution to our problem, to our math problem. So thank you for watching, and kindly subscribe. Okay, follow the steps.